So in this video, we're going to start with a new chapter called this chapter number 1, number systems. So in number systems, the first thing that we're going to see is what are rational numbers. So before jumping directly into the rational numbers, let's quickly do a revision of different number systems that we are known or that we have seen so far. Okay, so I've noted down the list of these number systems. The first one to go is natural numbers. Now in order to understand any number system, we are going to use the number line to understand or to visually represent what these numbers look like. So natural numbers, as we know, are, so first of all I'm going to draw a straight line here. Okay, so natural numbers, they start from 1. Okay, so we have our 1 here, and then we have 2, and then we have 3, and so on and so forth. Now this arrow is very important. This arrow represents that the numbers to the right hand side of the number line are infinite. Okay, dot dot dot. So natural numbers, in a very simple term, it consists of this number line. Okay, 1 2 3 dot 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 dot. Now next is, let's go down. Now the next set of numbers is called as whole numbers. So whole numbers, yes, whole numbers. So let's see what whole numbers include. So once again, I'm going to use this number line to understand the concept of whole numbers. Let's make a straight line first. Yes, and then we have this arrow again to the right hand side. Now in whole numbers, it starts from the number 0, and rest of the numbers to the right hand side are exactly equal to the set of natural numbers, this set of natural numbers that we have here. So after 0 we have usual numbers, which is basically 1 and 2 and 3 and dot dot dot. Once again, this arrow and this dot 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 are very important. They indicate that the numbers to the right hand side are infinite. Okay, so this is the difference between whole numbers and natural numbers. Only this number 0 is an additional is an addition to this set of natural numbers. Now next in line we have integers. So we'll quickly see what is integers. So for integers, once again I'm going to use my number line. So let's draw a number line here. Yes, okay, let's use a straight number line. So this is my integer straight. So in integers, the difference is that we have these arrows on both the sides of the number line. We have an arrow on the right hand side, we have an arrow on the left hand side, which indicates that the numbers are infinite on both the sides. Now let's start plotting our numbers here. So in the center we have 0, and then here we have 1 and 2 and 3 and dot dot dot. So to our right hand side we have all our positive numbers, we call them positive integers, and to the left hand side we have -1, and then we have -2, and we have -3, and again dot dot dot, infinite. So as you can see, to the left hand side we have all our negative integers, we call them negative integers. To our right hand side we have positive integers, and in the middle we have 0. So as you can clearly see that natural numbers and whole numbers are both subset of this integer set. Okay, so if we just focus on this part, this is our whole numbers from 0 to the right hand side. What we have done in integers is we have gone to the left hand side and included the negative numbers. And finally, last but not the least, is what we have, it's called the rational numbers. Now the rational numbers, okay, now the rational numbers do not have a visual representation like this above all 4 set of numbers, because these first 3 set of numbers we could represent visually using a number line, but for rational numbers there is no such representation. Rather, we have a definition of what is a rational number. So rational number is any number which can be represented in the form of p by q, or it's basically p divided by q, where p is any integer. Okay, so p can be any integer. So we know what integer includes. This is our integer set. So p can be any integer, and q also can be any integer, okay, except 0. So other than this 0, you can take any integer from this number line and use it as a q, and for p you can take 0 as well. So let's quickly see some examples of the form p by q so that we'll nicely understand what exactly can be a rational number. So let me use this different color. So 1 by 3. Okay, let me just write here examples. So examples, 1 by 3, is this a valid rational number? Take a look at this form of rational number, p by q. It is of the form p by q. P is any integer, 1 is any integer, q is any integer except 0. So q is any integer except 0. So 1 by 3 is a perfect example of a rational number. Now let's take another example. Okay, minus 2 by minus 5. Okay, again same thing, minus 2 by minus 5, is it of the form p by q? Yes. Is p any integer? Yes, minus 2 is one integer. And is q any integer except 0? Yes, it is minus 5. So minus 2 divided by minus 5 is a perfect example of a rational number. The only number which cannot be a rational number is something of the form 3 by 0. Okay, because q has to be any integer except 0. Why we don't allow 0 in the denominator? Because in mathematics the division by 0 is not allowed. It is undefined. It is against the rules. So we never ever use 0 as a denominator in any form of fraction. Thus in rational numbers we have this any integer except 0 rule. So I'm going to make it cross. Okay, I'm just going to mark it cross. So this is not a valid rational number. So thus we have quickly revised different forms of different form of number systems that exist in mathematics. The simplest one is natural numbers, 1 to 3. The second one is whole numbers, you just add 0 to it. Then we have integers, so you include the negative numbers as well as the positive numbers. And finally we have rational numbers, which is of the form p by q. Now one important point to be noted is that all the integers, okay, all these integers can be expressed in form of rational number. How is that possible? That is possible if we use q, if you use the denominator q equal to 1. Okay, for example, let's come to this side. Let's take this integer. Okay, so consider this integer 3. So 3 is an integer. So if I say 3 is equal to 3 divided by 1? Yes, I can say that, because any number divided by 1 is equal to the same number. So 3 is equal to 3 divided by 1. Also, now 3 divided by 1 is of the form p by q. Yes, it is of the form p by q, which means I have represented an integer 3 in a form of p by q, which is the form of rational number. Okay, similarly, you take any number from this integer set and you just divide it by 1, it becomes of the form of a rational number. So this is one very important thing, that all integers can be represented as rational numbers. Now finally in this video, one last point about these rational numbers which we have to remember is about the nomenclature. In fact, now this word rational, okay, it comes from the word ratio. I'm going to just write it down. It comes from the word ratio. Why is it called ratio? Because as you can see, rational number is in the form of a ratio of two numbers p and q. It is in the form of fraction. This is also called as fraction, if we remember. Okay, so since this set of numbers is of the form p by q, since it is in the form of a ratio of two numbers, we call this set as rational numbers. Now another last point is, all this set of numbers have a unique representation in terms of letter. So in mathematics, if I want to use a set of natural numbers or a set of whole numbers, instead of using this whole number line, we have a representation in terms of letters. So let's see what those letters are. Now again, there is no real logic behind these letters, so I'm just going to make a line here. Okay, so natural numbers are represented by a capital letter N. So let me just zoom in first. Yeah, so natural numbers is represented by capital letter N. Whole numbers is represented by capital letter W. Okay, integers is represented by Z, and rational numbers is represented by capital letter Q. Again, there is no logic, or there is no like a history or any line of reasoning that why these letters were chosen. It's kind of random. So whenever in mathematics we want to use the set of natural numbers, we use this denomination N, capital N. For whole numbers it's W, for integers is Z, and for rational numbers it's Q. So these are the four letter representation of the set it's a complete set. N represents this whole set of natural numbers, which are basically infinite numbers. Z represents this whole set of integers, which are also infinite numbers. So thus these are the alphabetical representations of these four numbers. These are number line representations of these four numbers.